Good morning, students. Today we are going to deal with the superposition of waves. You have seen in the beach that sea waves will be coming, and sometimes two waves from the sea will merge together and you will get a wave of big amplitude. Sometimes two sea waves will come, and when they join together, we will expect that the amplitude would be bigger, but the effect is the smaller amplitude. So sometimes when two waves join, amplitudes will be bigger. Sometimes when two waves joins, the amplitude will be smaller. How come that happen? That happened because of the principle of superposition of waves. Superposition means joining of two waves. So principle of superposition of waves describe how the individual waveforms can be algebraically added. How can they be algebraically added to determine the net waveform? That means we are not simply adding them to get the resultant wave. We will add them algebraically. That means if the crest and trough is meeting together, the wave will be nullified. But if crest of one wave and the crest of the other wave joins together, you will be getting a bigger wave. Similarly, if trough of one wave join with the trough of the other wave, you will be getting a bigger wave. But when crest and trough superimpose, we will get the wave nullified. That means you will be getting a smaller wave. So the definition of superposition, principle of superposition is like this. Principle of superposition states that, you can write this, principle of superposition states that when a number of waves traveling through a medium simultaneously, the resultant displacement of any particle of the medium at any given time is equal to the algebraic sum of the displacements due to the individual waves. So I have to write like this. The resultant displacement can be written like this: vector y is equal to vector y1 plus vector y2 plus vector y3 plus etc. vector yn. That means I have to look at the angle of the wave, I have to look at the phase of the wave, and only then I should decide whether I should add or subtract or whether I do vector addition. All those things can be assessed only by seeing the angle. So let us go to the example so you will understand it clearly. So after the definition, please write this equation also. So here I am discussing three cases. In the case 1, you can see one wave is like this, and as I told you, the wave is represented by yxt is equal to a sin kx minus omega t. You can either write omega t minus kx, or you can write kx minus omega t. It doesn't make any difference. So first wave is represented like this. Now second wave, y2 of xt, a sin kx minus omega t. Both the waves are having the same amplitude, and you can see both of them are having same phase itself. So just see, this is the pattern of the first wave, this is the pattern of the second wave. You can see both the crest and crest is coming in the same way, and troughs are coming in the same way. So crest is interfering with crest, trough is interfering with trough. So what will happen? The resultant amplitude will be 2 times the amplitude of the individual waves. That is why it is written 2a sin kx minus omega t. See, the resultant amplitude is 2a sin kx minus omega t, 2 times the amplitude of the individual waves. This is what happens when crust meet with crust. Okay, please take down. Now see the second case. When two waves are completely out of phase. Completely out of phase means the phase angle between them is 180 degree. If the phase angle between two waves are 180 degree, that means crust is meeting with trough. Crust is meeting with trough. So if crust meet with trough, what happens? The wave will be nullified and the amplitude will be 0. So you can look here, see the first wave, a sin kx minus omega t. It is going like this. Now see the second wave. When this wave goes up, this wave is coming down. So it is exactly the opposite of the first one. So when both of them joins, the resultant will be y1 plus y2, which is equal to 0. You can see the equations. First equation is a sin kx minus omega t. Second one, a sin kx minus omega t plus phi plus pi. There is an additional phase difference of 180 degree. So this can be written as y is equal to minus a sin kx minus omega t. So this is plus, this will be minus. So when you add both of them, you will get the answer as 0. So that is why the resultant amplitude is 0. Now see the third case. In the third case, the first wave is a sin kx minus omega t. Second wave is a sin kx minus omega t plus phi. There is a phase difference, but it can be any angle like 30 degree or 60 degree, something like that. It can be any angle. So I just marked two waves. First wave is like this and second wave I made it like this. And when both of them added, you will be taking the vector sum of both. We cannot simply add or subtract, we will take the vector sum of both. So the resultant amplitude is given by a sin kx minus omega t plus phi by 2. You no need to remember the equation now. This we will learn it later. In one derivation we will be doing it. So that time I will be explaining how this thing came. So when two waves are having different amplitude, you will be getting the answer like this: a sin kx minus omega t plus sin kx minus omega t plus phi. When you do that, you will be getting y is equal to 2a cos phi by 2 sin kx minus omega t plus phi by 2. This is what is happening during superposition of the waves. Okay. Stationary wave. Or standing wave. Stationary wave or standing wave means the wave which is stationary, wave which is not moving. So in a stationary wave, there will not be transport of energy, there will not be any transport of momentum. Energy is also not transported, momentum is also not transported. Such kind of wave is called stationary wave or standing wave. So the particle just vibrates simple harmonically, that's it. But no energy and momentum can be transported. Such kind of wave is called stationary wave. So how will a stationary wave propagate? That is what I am going to show. I tie one string on a rigid boundary and I pluck one end of the string. Okay, this is one boundary, that is another boundary, and I pluck one end of the string. So a wave will be propagated forward. So the wave is propagating forward. Okay. And when it touches this boundary, as I told you, there is a rigid boundary. If the boundary is rigid, then what will happen? The trough will be reflected back as crust, and crust will be reflected back as trough. So what will happen? You can see the crust is reflecting back as trough, and it joins with this. So this is the wave which is traveling in the backward direction. So one wave is traveling in the forward direction, and the orange color that I marked, that wave is traveling in the backward direction. So the wave which is traveling in the forward direction is carrying energy towards that side, and the wave which is traveling in the backward direction is coming towards the opposite side. So the energy of both the waves joins together, so the total energy transport is 0. Understood? Total energy transport will be 0, and you will get a pattern like this. This is called stationary wave. It is called stationary wave because the wave which is having forward motion will carry energy forward, and wave which is coming backward motion will carry energy backward. Both of them nullifies, so energy and momentum cannot be transported. That is why the wave is called stationary wave. And in a stationary wave, there are certain points where the displacement is 0. I will mark here, just see. There are certain points the displacement is 0. These points are called nodes. So nodes are the point of 0 displacement, and antinodes. Antinodes means the region having maximum displacement. That means this is the region having maximum displacement. So this is one antinode, second antinode, third, fourth, fifth, like that. Those are the antinodes. So nodes are the region of minimum displacement, that means 0 displacement, and antinodes are the region of maximum displacement. Okay, so that is all about the stationary wave. And what is the difference between a stationary wave and a progressive wave? Okay, that is what we are going to see now. The difference between traveling wave and a stationary wave. You can take down this. The waveform will move. That is why it is called traveling wave. Stationary wave, the waveform does not moving. And here the movement of waveform is always indicated by the movement of peak of the wave, because for a progressive wave the peak is just like moving forward. That is what we call wave motion. But in stationary wave, what I have drawn and show, those peaks always remains constant. Those peaks are not moving. The peaks always remains constant. Now the wave amplitude is same for all the elements in the medium, and the amplitude is denoted by A. So the amplitude of the wave is same for all the elements, but you just see the wave amplitude is different for different elements. There are some elements which are having 0 amplitude always. Those are called nodes. And there are certain particles which is having maximum amplitude. Those are called antinodes. So they will always vibrate with maximum amplitude, and the particles in the region node, in the node region, that particles will always remain there. That is why I told like this, wave amplitude is different for different elements. Now the amplitude is not dependent on the position of the elements of the medium, and here amplitude is dependent on the position of the elements of the medium, and here amplitude is determined by A, and here amplitude is changing. That is why the amplitude could be found by A sin kx. Now for a progressive wave, the general equation for progressive wave is yxt is equal to A sin kx minus omega t plus phi. Whereas for a stationary wave, the equation is 2a sin kx cos omega t. So, how we are getting this equation, we will discuss it in next section. This we have already done, this displacement equation we have already derived. How to make this equation, we will do it in the next section. Thank you.